All right, it's 4 o'clock. So we still have our third assignment for both CPM and AQR. If you are having trouble in any of these assignments or even the first or second assignment, please type in the skill, the IXL skill, into the chat box. Like, let's say you're having trouble on AA.4, which was actually the second assignment. That's okay. Just type it into the box, or if you have a specific problem, type it in as well. All right, thank you, Amber. So now the only thing is, I'm not too sure if you've noticed, but everybody gets different questions. So you're asking about skill set double A6, the second question. So that's probably fairly early on into there. So let me go ahead and open up my own IXL. And I'm going to go to Algebra 1 and scroll all the way down until I get to my double A's, and you're asking about double A6. So what I'm going to go ahead and do for you is I'll start working through these problems, and we'll see if that helps you out. So again, we are working on double A6, and the first problem that I have is 9t squared minus 6t plus 1. Now, what I would want to do is go to my interactive notebook and refer to page 35, which coincidentally I left in my classroom, at least the ones that we did this year. But if I go to one of my old notebooks, I have it right here. So what I want to do is first take a look and always ask yourself, is there a GCF? So 9, 6, 1. I'd have to say no GCF. So I'm going to write that off to the side. This might look kind of familiar. This is what we had done in class. So no GCF. So then we take a look and we ask ourselves, do we have a binomial or a trinomial? Now, in this case, we have a trinomial. So I'm going to keep moving down the list here. So since I don't have a binomial and I do have a trinomial, I'm going to ask myself, is my A value, is my leading coefficient equal to 1? My leading coefficient is 9. So that's where, no, we know that we need to use factor by grouping. So we would flip the page over and continue from this point forward. I'm going to move these notes over, though, because I really don't need that right now. So we're going to do factor by grouping. So I already checked for a GCF. Now I'm going to identify my A, B, and C. So my A, we already discussed, was 9. My B is -6. And my C is +1. So we're going to take my A and my C and multiply them. And that would be 9 times 1, which is simply equal to 9. Absolute value of 9 is 9. So we're going to go ahead and write out all of the factors of 9, starting with 1 times 9 and 3 times 3. Now that we've multiplied these two numbers, we're going to find which of these pairs will give me my B value. negative 6. And obviously, if I take negative 3 minus 3, that equals negative 6. Now, this is where you guys probably need a refresher because we haven't done factor by grouping in a while. Now, factor by grouping is a little different because what we're going to do is we're going to replace this negative 6t with negative 3 and negative 3. So I'm going to bring everything else down. I'm going to say 9t squared and then minus 3t and minus 3t. Then I'm going to bring down my plus 1. Okay, so what I'm going to do is I'm going to take this new 4-termed polynomial and I'm going to split it down the middle. All right, now I get to take a look at the left side, which is 9t squared minus 3t, and I'm looking for a GCF, just like we were doing in our skill set double A1 and double A2. I'm going to take that GCF and factor that out. So in this case, they both have a 3 in common, and they also both have a t in common. So I'm going to factor that out, and that should leave me with 3t. And this is where you guys were having a lot of trouble on your double A2. Here, I do have to put a 1. Because I have 2 terms here, that means I should also have a binomial inside of the parentheses. Now, remember, whatever I have inside of these parentheses, I should have over here as well. So I'm going to go ahead and just write that out, 3t plus 1. Now, what times 3t is going to give me negative 3t? Obviously, that should be a negative 1. And you probably caught my boo-boo there. I'm sorry. That was supposed to be a minus 1. And to double check that one there, negative 1 times negative 1 gets me a positive 1. So this is absolutely correct. Now, because this is the same, you're going to bring that down. That's going to be 3t minus 1. And then for my other factor, my binomial, I'm going to take down these 2 terms, which is 3t minus 1. Oh, well, it's actually the exact same thing, isn't it? And that's okay. So this would be my final answer, and I'm going to go ahead and type that on in here. Oh, oops. Click on. All right. Now, the reason I like using the app is because it only gives me one variable, and I'm slightly dyslexic. I mess things up all the time because I'm only human. Ooh, I like that. It gave me my double parentheses. I didn't even have to do anything else. Now, here, I could write it 2 different ways. I'm going to see if it's going to count it wrong, but let's see. Because I could have written it like this, or because it's the exact same thing, I could have also written that. But I'm going to try it out and see if it gives me any sort of problems. Okay, submit. Okay, good. Now, actually, Amber, quick question before I move on to this binomial. Do you want me to check the exact question that you got stuck on? And we can do that one? I'll pause to see your response in the live chat if you want me to specifically do the problem that you got stuck on. Okay, I don't see a response just yet. So think about that. If you'd like me to do your specific problem, let me know. If not, I'm going to go ahead and move on to this binomial. And this binomial says m squared minus 9. Now, myself, whether or not I have a GCF with these two terms, and I do not. Oh, okay, cool. All right, just wanted to make sure. So, no GCF, and this time we do have a binomial. Because I do have a binomial, I need to double check to see if I have the difference of squares. So, recall, difference of squares. I'm going to write that over here. Difference of squares. Okay. I'm going to use my two different colors as well. Okay, good. So that says that I'm going to have a squared minus, which is the difference, b squared is equal a minus b and, let's hope this fits, a plus b. This is what sucks about having these fat markers, but you know me, I need color. Okay, so difference of squares. Now taking a look at this binomial, does it look like the difference of squares? And I would have to say, yeah, it really does. I just have to rearrange it so that it looks like, I don't know why I closed my markers because I want to have all them colored as usual. I want it to be something squared minus something squared. Now in this first red set of parentheses, obviously I would put m. But here in this blue set of parentheses, not as obvious, but we know our perfect squares listed on page, I can't remember off the top of my head because we've been out of school that long and I can't find my folder because it's over here. All right, here we go. So perfect squares. Man, we have done a lot of notes. I thought I was up in the front. Let's see. Here we go, page 5. Sorry. So looking at page 5, which I don't think mine was ever filled out because I filled it out for you guys and I gave it out to somebody like a dunce. All right, so page 5, look at your perfect squares. You'll notice 9 is listed down as 3 squared. Now notice the 3 is inside the parentheses. That's really important. So now I can go ahead and set up my two parentheses. And I love this because literally you just fill in the blanks. So here, my blue 3's go there, and my red m's go here. And ta-da, I've got my final answer. So, m minus 3, oops, too many m's, and m plus 3. Now, remember, I could have written m plus 3 times m minus 3. It is the same thing as saying it doesn't matter if the plus sign comes first or the negative sign comes first with your difference of squares, okay? It can be interchangeable, same thing, submit. All right, let's go ahead and continue. Oh, looks like we have another nice one here. All righty, so here I have 16h squared minus 1. So I would take a look and check to see if I have a GCF, which I do not. And then I would check to see whether or not I have a binomial or trinomial. Two terms, I have a binomial. Now, do I have the difference of squares? Well, I think I could rewrite it. Now, again, I want something squared minus something squared. Now, this one is the easiest one to fill out because 1 times 1 is still 1. Okay. Now, h squared, there's going to be an h inside, but 16. You'll also find out on page 5 that 4 times 4 is 16. So here I would have h squared. And then that makes this part really easy because I could say 4h and then minus 1. That's an ugly looking 1, but you guys get the point. And then times, again, 4h plus 1. Now, like I told you guys on your previous exercises, I would highly recommend have some scratch paper so that you can write this stuff down. You don't have to turn it in, but seeing your answer really makes it easy before typing it in. Some of these might be very easy, like the AA1 and the AA2, that you don't have to write anything down. But as we continue, it's going to get a little bit more difficult. So you definitely want to make sure that you're at least showing your work to yourself before submitting, because then you're going to get really frustrated that you're getting things wrong. All right. Ooh, I love this one because we haven't done a tutoring session with this one yet because nobody asked for any problems. This one looks kind of like what we have in our AA4. And that's really nice and easy. That you can find on page 34. Here we have g squared plus 2g plus 1. Now, taking a look at your terms, I do not notice a GCF, but I do notice that it's a 1, 2, 3 trinomial. Now, because it's a trinomial, I want to then recognize my A, B, and C. My A would be 1. My B would be 2. And my C would be 1. Okay, so because I have my A is equal to 1, like I told you, would refer to page 34. Where it has all them steps and all those puzzle pattern boxes, which is a term I made up and was really frustrating to you guys because you didn't know what to call it. I'm sorry. I'm making stuff up as I go. So, if you recall, we have 2 boxes in the middle, and after doing the puzzle pattern boxes above in the examples, you had recognized that, man, do I have any more colors? Let's see here. I know. Seriously? This wants more colors? Yeah, of course I do. Yes, I was looking for pink. Okay, because I think that's the way that we had in our notes, that up on top was our product, which was our C value, and down below was our sum, which was our B value. So I'm going to put my B value here, my positive 2, and my C value of positive 1 goes up on top. All right, so what you guys have recognized is that we're going to have these 2 values are going to multiply to give me 1, and they are going to sum up to give me 2. Okay, if you take a look at page 34, step 3, it says list out the factors of A, which is 1, times C, which is 1. So the absolute value is 1. And of course, 1 times 1, that's all we have. So we would say that I take my positive 1 and add a positive 1, that gives me a positive 2. So plus 1 plus 1. Now I could write my final answer as G. I don't know why I closed that. And then that purple plus 1 times G plus 1. Now, just like we had done before in double A1 and double A2, if you really, really wanted, you could multiply out your final answer and it should give you your original trinomial. Do you have to? No. But if you're not sure before you want to type it in, fine, get the extra practice. But I'm going to go ahead and type it in as G plus 1. And again, G plus 1. Submit. Submit. Off. All right. Now, please do stop me if you're getting bored with these problems, and we can move on to a different subject. But if you're good and you want to get some more practice on these, I'll continue. I'll keep popping my head up to check on the live chat, all right? But for now, I'm going to scooch that over and move on to, ooh. Well, I guess so. We're starting to get a little bit harder here. So I have 16y squared plus 24y plus 9. Now, first thing is I'm going to check for a GCF. All right. So I'm going to scooch that one over. Always check for your GCF. Now, 24 and 16 both have a 4 in common. Then I have this odd number, 9. It is not divisible by 4. And because it's odd, it's also not divisible by 2. So I would have to say no. There is no GCF, which kind of sucks. But hey, let's go ahead and keep moving forward. Now, we do have a trinomial. So we have to recognize that A is 16. At least 6. There we go. B is positive 24. And C is positive 9. Okay. So I'm definitely going to be using my multiplication table on page 4. Because once I've recognized my A, B, and C, I have to multiply 16 times 9. You know what? Now that I think about it, though, I did show you guys another way that you don't have to use your times table. I'm pretty sure a whole bunch of y'all are using your calculators. Yeah. I'm not completely out of loop there. But I'm going to go ahead and break this up here. This could be 3 and 3, and that would be 2 and 8, and 8 is 2 times 2 times 2. Yeah, there we go. So I'm going to first take a look here. Whoop. I have too many markers on my desk, and they're about to all fall off. All right, so 16 and 9 is 144. And 144 is made up of all that mess. So I'm going to say 1 times 144, which that would be 7, 8, 9. And then let's see here, that would be 2 times 2, 4, that's 8 times 9. Which is 72. That's where I was getting the 7 and the 2. We do have 3 here. So then 16 times 3 would be 48. Now here I have 2 times 2. So that's 9 times 4, 36. I can't make any 5s here, but I could make a 6. So that would be 2, 4, 8 times 3. So first off, let me put down my 6. And then 8 times 3. 24. 7. I can't make a 7 out of those numbers. But I did already say I could make an 8. So that would be 8 times 9 and 2. That would be 18. Speaking of which, 9 times 16. Could I make a 10? 2, 4, 6, no, I'm not seeing a 10. Definitely can't make an 11. 12, I could make a 12 right here. That would be 4. So let me put down my 12 first because I'm bouncing out. I'll hope it 4 times, hello, 12 times 12. Oh, goodness. All right, so I'm definitely done. All right. So remember, what I was doing here was breaking up these numbers. So that was going to be my 2 times, and then 2, 2, 2, and then 3, 3, which was getting me my 72, so on and so forth. Okay. So whenever you are stuck without a calculator, which I think you guys might be really, really hindered whenever you come back, you probably have been using the calculator on this little bad boy to help you out. So coming back around though, we're going to check to see which of these will add up to get me 24. Positive 24. So too big. Ooh, this one looks nice. So if I plus these two, that gets me a positive 24. I usually like to go at the bottom at the top and try and scratch off what doesn't make sense. Like that's nowhere near each other. So you're kind of looking for something that has numbers that are fairly close to each other. This would either be 144 or 143, positive or negative. So that's a good way that you can try and determine, but I'm seeing 12 and 12. So let's go ahead and break that up here. We have 16y squared and then plus 12y and then plus 12y and plus 9. Again, we're doing factor by grouping, so let's group it. Split it in half. Now we're going to take a look at one side. We have 16y and 12y. They obviously both have a y in common. So yeah, we'll pull out the y, but they also have a 4 in common. Would be the biggest number, I think. So let's pull out 4y. So that would leave me with, again, 4y plus 3. So that means I should have 4y plus 3 over here as well. Now, what times 4y would give me 12y? Well, that should be a positive 3. So that gives me that, and this will also give me 9, which is perfect. So, oh man, it gave me another one of those. Oh well. Let's bring down our two terms here. That would be 4y plus 3. And bring these down over here. 4y plus 3. Okay, let's go ahead and write that out here. I'm actually going to write it down as 4y plus 3, and I'm going to write a squared on the outside. Will it let me? Oh, yes, it will. That it's been giving us where it's something squared. That would be kind of like what we wrote out on page. Just bring it up here. I hope I wrote it down here. Difference of cubes, difference of squares. Oh. Let me double check, because now that I'm thinking about it, maybe I didn't give you this formula yet. I did, never mind. So this is the square of a sum. I'm going to write this one out. I want to show it to you. Square of a sum. So maybe that'll help us just immediately identify it before we have to just do all this factor by grouping, just to find out that it's the answer is actually just 4y plus 3 squared. So let me show you what this looks like. It's very similar to difference of squares. because it's going to say, scooch that up a little. It's going to have A and then plus B. Use some different colors. Squared is equal to A squared and then plus 2A times B. Whoa. And then plus B squared. So the way that you can recognize this is if you take a look at your original A and C. You'll notice that I have something squared and I also have something squared. So if I had written it out, rather than doing all this mess here, I'm going to put a box around that. I could have tried saying, well, if this is 4y squared, and then plus 2, and then leave my blanks there, and then plus 3 squared, well, then I could come over here and try and fill out these blanks. Well, if I put in 4y here and a 3 right here, does it give me the exact same answer? Well, that's going to give me 16y squared. And now here, you can do this pretty much any way you wish. I'd probably leave the 2 to the end. I would say plus 2 times 12y plus 9, which ends up giving me, yeah, the exact same answer in the beginning. Now you'll notice this is kind of very little work here. So once I see that, yes, it gives me the exact same thing, I could rewrite it as 4y plus 3, that marker's here, and then square it. So if you know your square of a sum, which is on page 30, and you recognize that both your A and your C are perfect squares, you could simply do a lot less work. And I'll try doing it on the next one that I recognize, okay? Rather than making you guys do a whole bunch of factor by grouping. Sorry about that. So let me move on to the next one on my phone, which is a binomial. So it's a nice little break from here. This one is nice and easy because it's 9t squared minus 4. So first off, do I have a GCF? Well, 9, 4, I'd say no. No GCF, but it is a binomial, so I immediately recognize that it is a difference, and I do have some squares here. So let's go ahead and rewrite this as something squared minus something squared. Okay, so my 4 is very simple to fill in. 9t I could probably replace as 3t. It's just nice and simple. So let's rewrite parentheses 3t minus, scooch some of these markers up, there we go, 2. And then of course 3t plus 2. Perfect. have a difference of squares. And probably this one, the only thing you'd have to write out on your scratch work would be up here. But I recognize it's a difference of squares. I would probably start typing it in myself. Oh, I swear, I'm so dyslexic. I saw that F and I saw it upside down as a T. Oh, well, it's F. So 3F. Go. And then minus 2. And then 3F. Oh, goodness. Who's in my driveway? I tell you, I hate this. Oh, okay. 3T or 3F. And then plus 2. All right. And submit. Now, I would definitely say these are taking a bit longer, and that's why I only give you 3 of these IXLs for this week, because they do take a bit. Ooh, now I've got something a little bit more interesting. Let's hope I write down the correct variable this time. So that's again why I like the app, because I probably would have typed it wrong into my computer. So 16J squared, and then plus 56J plus 49. Now, I recognize that 16, that's 4 times 4. 56 is 8 times 7, so 4 goes into both of these, but 49 is 7 times 7. And that sounds like a perfect square, just like 16 is. So that means, let's check to see if I could do a square of a sum. So let me get my 2 colors again. Okay, so let's check it out. So what would go here? Probably a 4 and a J, and squared, plus 2, and then 4J. And I'm going to leave my parentheses right here for right now. I'll come back and fill them in. And then plus 49, I already know that that would be, oops, wrong color. I love erasable things. That would be 7 squared. Okay, so that means I put my 7 over here as well. Okay, now this one absolutely gives me my 16J squared, and that gives me my positive 49. Now, 7 times 4, that's 28, and 28 times 2, that would be 40, and then 12, and then 6. Alrighty, that would be 8 times 7, 56. All right, so it totally works. Now, because it works, I'm just going to scratch that off. I was just doing that for my brain. I can go ahead and write down my final answer as 4J plus 7 squared. And that would be my answer. So let's go ahead and type that in. And that would be 4J plus 7. And then square that whole bad boy and submit. Yay! We're almost to a passing grade. Okay, let's go ahead and move on to the next one. It looks like we have another one of these special square of a sums. I'm glad that we kept on moving forward with this because I want you guys to work smart, not hard, especially right now. I get it. What are you guys thinking about this IXL anyway? Yay or nay? A question for one of my problems on. Oh, good. So you want me to scratch this one for right now? And we'll move on to AA7? I don't like it. Well, while you're thinking, I'm going to look up to see what problem you're stuck on for AA7. Hopefully my computer wants to work with me. Oh, come on, computer. There we go. Just 1 minute. Oh, Amber, I love your name because you are the first person that always pops up no matter what. Okay, let's see where you're at. Double A6. I don't see double A7 just yet. Give me just one quick moment. Double A6. Sorry, give me just one quick. Oh, okay, here we go. Let me see who's in here right now live. We only have 3 students here. There we go. I see Amber. Alright. Still doesn't want to show me the double A7. What's the function? Amber, it shows that you're in double A6, not in double A7. Can you double check what problem you're on, and if anything, maybe send me a screenshot because as I'm looking at you live, I show that you're on double A6. Maybe I'll write down the last problem that you were on. No, no, that looks like that's the easy stuff. So let's see. Oh. Could you type out the exact problems that you have? Because I don't see exactly what you have right now. I don't know if it's just lagging right now. Because I would say that if it has a negative, that this wouldn't work because they should both be positive. But I don't mind working that one out with you. Yeah, go ahead and type in the problem into the chat because for some reason I can't see the one that you're working on right now. I don't know why it's being weird with me. Yeah, all I can see are the 5 problems that you have already done. I can't see the one that you are currently working on. Once again, what would you mind typing in the problem that you are currently working on? Because I can only see the ones that you have already attempted to answer. All right, there we go. Thank you. So you have 9q cubed minus 9q squared minus 7q plus 7. Is that correct? Just want to make sure that I wrote it down correctly before I continue. So, yes or no? Oh, wow, that looks really bad. Yes or no? Okay, I am not getting anything. I mean, this is what you said, so I'll go ahead and move on forward with this one. Now, taking a look, I have 9977. I don't see a GCF with any of these numbers because I have 1, 2, 3, 4. So I don't have a GCF. I don't even have a trinomial. I have a 1, 2, 3, 4 term polynomial. Now this is actually our factor by grouping because we're already halfway through. Now when you group it. So that's why this one's a little bit confusing because it's kind of ugly. So because I have 4 terms, I already know that I should be using factor by grouping, so I'm going to split it in half. Now, taking a look, I notice that both of these have 9's and q's in common. As a matter of fact, it has 9q squared in common. So I have 9q squared times q gets me 9q cubed. Say that 3 times. 9q squared times its negative self gives me negative 9q squared. Okay, so in that case, I already know that I should have q minus 1 over here. And now, what times q will give me negative 7q? Well, sounds like negative 7. And negative 7 times negative 1 gives me positive 7. Perfect. So in that case, let's bring down our 2 terms. That would be 9q squared minus 7. And our 2 black factors, q minus 1. And that's it. You're done. Oh, sorry, there must have been a lag. That look correct for you, Amber? I'll go ahead and pause and wait for me to wait for you to see what your next question would be. Or would you like me to just start going into double A7 now? Would you like me to try and do a couple more from the double A7 at this point, Amber? Go ahead and continue here. Yes, okay, thank you. All right, I'll go ahead and continue with the ones that I have on here. Unless you have a specific one, then you can type it into the chat. But for now, like I said, if you have 4 terms, you're immediately going to do factor by grouping, which as a matter of fact, if you take a look, double A7, I don't know if it's probably coming out blurry there, but it says factor by grouping. So page 35. All right, so now we're moving to double A7. Oops, I should have turned that off. It's probably going to give me a new one. Oh well. This one will be 10k cubed plus 20k squared minus k minus 2. All right. Now, it's already done all the hard work for us. If we take a look, sure, I have a GCF here, but I don't have one all the way through. And we have 4 terms. So in that case, we're just going to already know we're doing factor by grouping. It already multiplied out and it gave us our 2 terms in the middle that add up to give me my B. So that's why this one's a little confusing. So since we already have our 4 terms, you split it down the middle and you start factoring. Now, 10k cubed and 20k squared, well, obviously they both have 10 and they both have k. Always look for the lowest exponent squared in common. So here, I'm missing 1k, and then 10k squared times 2 should give me 20k squared. So let's bring over k plus 2 over here. Now, what times k is going to give me negative k? It's like negative 1. And negative 1 times 2, that's negative 2. So, don't you like this? This is nice and simple. It's breaking down that factor by grouping and giving us just the simple part first. And then we have k plus 2. Perfect. So let's type that in. Oh man, now I have to write out everything. Ooh, 10k and then squared. Oh, that's nice. I like that a lot. Then I won't mistype things because Lord knows I will. And k plus 2. Okay, good. I'm glad I know how to type. All right. Seven x cubed minus 7x squared minus 3x plus 3. Again, we are in the factor by grouping section, so I already know that I can just split it down the middle. Of course, double check to see if by chance all 4 of them have something in common, but they don't. So I'm just going to move right down to splitting them in half. And both of these, it's really obvious. They have a 7 and they also have x squared in common. Now, if you were having trouble with double A2, this one's probably going to give you some trouble as well. Okay, good. So remember, you want to break it up. That would be like 7 and then x minus 7x. So I see here I have 7x squared in both. And I like that because then it's kind of like what we were doing in double A2. Whatever's left over goes in the parentheses, which is x minus, and since everything is circled, 1. So I can put that over here, x minus 1. And negative 3 goes here. That gives me negative 3x and positive 3. Yeah, you let me know if you want to switch on to a different topic or if you want me to keep going. Okay, I'll keep looking up in there. Just let me know. I will do whatever you guys want to do. Minus 3, then x minus 1. Okay. Ooh. Nope. All right. So this one isn't as obvious as the first two were because obviously it's getting a little bit more difficult. So we have 6w cubed and then minus 3w squared plus 16w minus 8. Now before we kind of had like the exact same numbers. This time we don't. So I already know right here we don't have something in common. So let's go ahead and move to splitting. Notice that I'm keeping the sign with the number. Now here, if I were to break that up, that would be 2 times 3w, and this would be 3, negative 3, w. So it's obvious I can pull out 3w squared, and then that leaves me with 2w, since everything is circled here, minus 1. So let's bring over 2w minus 1 and figure out what goes in front. So what times 2w gets me positive 16w? Sounds like an 8. And 8 times negative 1, that's negative 8. So for it being a little bit more difficult, it wasn't that bad. As long as I write it correctly, my goodness. 2w minus 1. Let's move on to the next problem. We'll just double check and see if you guys have specific questions. Alrighty, so in this case here, I have 10j cubed minus 5j squared minus 14j plus 7. Okay, I don't see a GCF in all 4 terms. So let's split it down the middle. And I'll break it apart just the same way because that might help you guys. 2 times 5 and then 1, 2, 3 of those. Minus 5 and then 1, 2 of them. Now they're being pretty easy with y'all. They're pretty much just taking out the second term there, which is 5j squared. And they're leaving you with 2j minus 1. So 2j minus 1. What times 2j is going to give you negative 14? Negative 2. And negative 2, oh, sorry. That wasn't right. Negative 7. There we go. Times 2j gets you negative 14j, and negative 7 times negative 1, positive j. Sorry, that doesn't really look like a minus sign. There we go. Okay, let's type that on in. Hoping I'm not typing anything wrong. Oh, goodness. Tell you, this warmer weather's coming in. Okay. This time we have 3v cubed plus 3v squared. Oh, it looks like they gave us another easy one. So I'm kind of going to go through this one a little bit more quicker because we've already done this. So again, I'm looking at that second term, 3v squared. I'm just missing a v plus 1. So then v plus 1, negative 8. Okay, so then 3v squared minus 8 and v plus 1. And again, you can switch your factors around. If you wanted to write v plus 1 first, you are still correct. And then you could write the 3v squared minus 8 after it. Just make sure that the minus sign stays with the 8 and the plus sign stays with the 1. You would have to move the entire factor around, not term. Sorry. Let's see if it gives us one that's a little bit more difficult. Okay. All right, so taking a look here, I don't see a term that goes into all of these because of that 19 there. So let's split it up right in front of that positive 19. Oh, this one's a little bit more interesting because it kind of breaks the rule that we had on that previous one. So here I have, I'm actually going to leave that 9 together. So that would be 9 and then in. Now, the reason I left that 9 together instead of splitting it up is because I see I have a 9 in here. 2 times 9 and then in. Okay, so that means that I could take out 9n squared from both. 9n squared. And that would leave me with n plus 2. N plus 2. And now, what times n would give me positive 19n? Well, that sounds like, well, just 19. Now, 19 plus 19, that would be 8 and 2, 3. That's 38. So real talk right now as I'm just rewriting my answer. I don't know if you guys can hear this, but there is an ice cream van, you know, like they sell all those cheapo looking versions of Spider-Man as a popsicle, in a van that's colored green and yellow. They live up the street from me and they always hit up my neighborhood first, obviously. And oh my goodness, never fails. My neighbor in front of me always stops them every freaking day. And so he's playing like Christmas music on this super pixelated sounding sound system. And they park in front of my house and they just play it all the time. And it drives me nuts because somehow I can't hear things that are going on downstairs, but I can hear that stupid ice cream van there for at least 30 minutes while they all 5 of his kids go get ice cream and have Cheetos and cheese. Oh, it drives me nuts. Sorry. Can we do one with a GCF? Yeah, I wonder if there is one. Can't remember if there were any that had that. Let's see, like this one has tree. No, that one doesn't have one. Here, give me one quick second. Unless, do you have one that you got stuck on? If not, give me a moment and I'll run through these really quick. Give me a moment here. Put my hand in. You hear that right now? La, 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 la. Oh, God. And the teacher was talking about putting up their Christmas tree, and I was almost for it until the stupid ice cream. Let's see if the next one has a GCF. Dang it, it almost did. Okay, so then that has... Sorry, I'm trying to run through these as quickly as possible. Well, this one doesn't have a GCF just yet, but I think I would like to go over this one with you just because it has a commutative property on it. So this one states you have 4u cubed minus 5 plus 4u squared minus 5u. Now, usually you guys would say, okay, well, I have 4 terms, so I'm going to split it down the middle because the 4 terms do not have a GCF. Now, the only thing is that if I split it down the middle right now, there we go, now you can see it. You'll notice that 4u cubed minus 5 does not have a GCF here, even though 4u squared minus 5u does. So commutative property of addition tells me that I could rearrange these. Even better, you could rearrange them in descending exponential order, which is correct. So I'm going to do that. I'm going to say 4u cubed plus 4u squared, and then minus 5u minus 5. This is in descending exponential order, and I use the commutative property of addition to rearrange it. So now I can split it down the middle and take out my GCF here. Now, if you want, you don't have to do the left side first. You can do the right side because it's very obvious that they both have negative 5 in common, leaving me with u plus 1. So then over here, I can bring over my u plus 1. and put my 4u squared here. So that would be 4u squared minus 5 and my u minus 1. Plus 1, sorry. So I'm going to type that in real quick. 4u squared minus 5. And then u plus 1. Let's see if we finally get a GCF, because I'm at like 68 points right now, so I would assume that would go up. 2, 2. No, they just have, I'm kind of wondering if they have any with GCFs right now. I could make one up. But this one is a little different because it has bigger exponents. This one has 2j to the 4th minus 4j cubed, and then plus 3j squared minus 6j. Now, in all technicality, all of these do have a GCF. So I guess we could write them in different manners. Let's go ahead and try starting off with the GCF, which you'll notice all 1, 2, 3, 4 of them have a j in common. So I could take out the j, and then that leaves me with 2j cubed minus 4j squared plus 3j minus 6. So here we go. Finally, we got to a problem that you wanted. Now, they are in descending exponential order, and they no longer have a GCF. So I can go ahead and start factoring. As a matter of fact, you know what? I think I'm going to put this GCF with the J in green, just so that I won't forget that it's there. I think I just needed to look. Yes. Do you want me to finish this one right now? Because it finally has a GCF. Oh, okay, well, I would assume you do want me to go over it because that's what your previous statement said. So I'm going to finish this one up and then I'll move on to AA8. So here, I'm going to start over here because they both have a 3 in common. And that would leave me with j minus 2. So j minus 2. And then I would have 2j. Gives me 2j cubed. And then minus 4j. Oh. That one should be squared. There we go. Now that gives me cubed. And now 4j squared. Okay, perfect. So this is the way this one would look. 2j squared plus 3. And then j minus 2. But we cannot forget my j, my GCF j in the very beginning. So let's type this one in. This one's really weird. J. You guys can see it a little better. And then 2j plus 3. And then j minus 2. Oh no, what did I miss right? Let's see. J, 2j squared plus 2. Okay, I mistyped it because, oh, I forgot the squared. Oh, you see, I'm human. So I absolutely got the right answer. It says the correct answer is right here, and I wrote it correctly, but I typed it incorrectly. I forgot my stupid squared. All right. So at least you finally got an example, and I did all the work correctly for you. You wanted the AA8, which is AA8 is just factoring polynomials. I like this one because it's all of them. You might have a difference of squares, square of a sum. You might have trial and error or factor by grouping. So you really have to go through your steps to double check on these because it's going to have all of them combined. So on my first problem, it's very simple. It's 9z squared minus 1. Of course, you can recognize that it's a difference of squares. So 3z squared minus 1 squared. So that would be 3z minus 1 and 3z plus 1. Okay. 3z minus 1 and 3z plus and it's typed here. Oh goodness. I tell you, technology. There we go. Let me try that again. 3z minus 1 and 3z plus 1. Now, before I push submit, what you'll notice here is it kind of gave you a super hint because it has the option to put the double parentheses here. So it already lets you know that you're going to have one of these nice situations. Push submit. Okay, let's move on to the next one then. Now this one is 4j squared plus 4j plus 1. So what I'm noticing right off the bat is that I have a trinomial with no GCF, but it's all sum. So I could possibly have this if let's check these out here. So that could be 2j. That doesn't look like a j, but you know what I mean. There we go. And this could definitely be a 1. So that's 1. And then 2j. And then squared plus 2 plus squared. Okay, so that should give me 4j, and that looks correct. So I should have 2j plus 1 squared. And you'll see again, it gives me that hint, because I have that set of parentheses right here that I could type in 2j plus 1. So it's kind of giving me hints whenever I have special features or special situations. See if it's going to give us another nice one. No, it's not going to give us another nice one. Instead, it's going to give us a factor by grouping because I have 4 terms, like 10y cubed plus 15y squared plus 8y plus 12. Okay, so 1, 2, 3, 4 terms do not have a GCF. Split it down the middle. And let's see here, that's definitely, they both have 4 in common, and that's y plus 3. So let's put our y plus 3 here. And so that would mean, 2y plus 3. Sorry. Yeah, because that would give me 8y. and that would give me 12. Okay, so then I have here 5y squared, and this gives me 10y cubed and 15y squared. 5y squared plus 4 and 2y plus 3. Okay, let's hope I do not mistype this time. Plus 4 and then 2y plus 3. Okay, I'm going to double check before I push submit. I hate whenever I do that. Okay, perfect. Now this is a trinomial. 25v squared plus 20v plus 4. These both have 5 in common, and these both have 4 in common, but all three of them, no GCF. We do have a trinomial, and my a value is not equal to 1. So, because my a value is not equal to 1, I'm going to have to use page 35 factor by grouping, which this one is more aligned to it. So I'm going to take the a, b, and c, a being 25, b is positive 20, and c is positive 4. A, 25 times c, the absolute value is 100. So let's find the factors of 100. Oh, goodness. So that's 1 times 100. So that's like 2, 2, and 5 times 5. That's going to help me out right now. So 2 times 50. I can't make a 3 there, but I can make a 4. And I do have a 5 here. So that's 5, 10, 20. I cannot make a 6, 7, 8, 9. I can make a 10. Of course, 10 times 10. And that means that we're done. So we take a look to see which of these will add or subtract to give me positive 20, which is really easy here. Oh, yay. I'm seeing some new people joining on to Google Classroom again. That makes me happy. So let's bring this on down. 25v squared plus 10v plus 10v and plus 4. Well, that looks really tiny. Sorry about that. So now that I have my 1, 2, 3, 4 terms, I can split it down the middle and start factoring. So these two both have 5v in common, leaving me with 5 and then v. 5 times 5 is 25v, 10, okay, and then plus 2. So that means this one should have 5v plus 2 over here. And what times 5v would give me positive 10v? That's 2. Oh no, I'm such a dunce. I didn't see it. Oh, I did have a square of the sum, and I see it now, obviously. So 5v plus 2. Man, I was slipping. I was thinking to myself, wow, finally they have this. But nope, they were nice, and I didn't catch it. I could have said 5v squared, and that could have been 2 squared. And then plus 2, 5v, 2, that'd be 420. Yep. Dang it. Oh, I should have known better. And it even gives me that little parentheses there. Oh well, plus 2. And then let's square it. Should have known better. I was like, man, they're going to give me that. Now, in this case, I'm double checking. This one we don't have perfect squares. So I should have done, this is a true factor by grouping. 2v squared minus 13v plus 11. Okay, so that's because I got some prime numbers in here. I do have a trinomial. My a is not 1, and just to double check, I do not have perfect squares for my a and my c. So that means I can identify my a, b, and c. A is 2, b is negative 13, and c is positive 11. Okay, so we're going to take 2 times 11, which is 22, and we're going to find the factors of it. So 2 times 11, absolute value is positive 22. So that would be 1 times 22, 2 times 11. And since 11 is a prime, that's all that we have here. So we want to try and make my b value, which is negative 13. Ooh, there we go. That's how I can get it. So I'm going to bring this on down. That would be 2v squared. And split that up into negative 2v minus 11v plus 11. All right. Factor by grouping says I split it down the middle, and you can rearrange if you want to, but you probably don't want to because I see 2, 2, 11, 11. That looks perfect to me. So both of these have a 2 and a v in common. So therefore, I can have a v here minus 1. So then v minus 1 over here is just missing my negative 11. Yeah, that would be perfect. So 2v minus 11. Sorry. And v minus 1. Love it. Oh, you know what? Maybe it's not a hint because here I have 2 different factors and it's still giving me that double parentheses. 11 and then v minus 1. Make sure I wrote it correctly. All right, so I know that I did leave you guys here at 43, but at the same token, I see a difference of squares, so I could simply write that as 3w minus 5 and 3w plus 5. But I also see that it's already 5:30. I know some of you guys are working. Do you think we could do another square of some after that? Okay. Okay. I was about ready to say let's call it quits, but let me see if I can find you one. Dang it. This one is not one, but it is something special. Okay. How about I make one up? So a square of a sum. Let's say that we had, I'm going to touch it so we got a count. Oh, no, I have. Okay. So this one I did make up and it has horrible looking numbers. Now, the thing is that you take a look and here I have 9, 450, and 25. Now, 25 and 450 obviously have 25 in common. Think of money, 25 cents, $4.50. You can use quarters to make $4.50. But you cannot use quarters to make 9 cents. That makes no sense. So instead, sorry, this is like really twinkle. Whatever. There. What you'll want to notice is because, yes, it does not have a GCF. It is a trinomial, and A is not equal to 1. According to page 35, you would have to use factor by grouping. But before you go crazy and do factor by grouping, double check this over here. Because it is a trinomial, and I do have pluses all the way through. So let's make sure to see if we could by chance set this up. Something squared. Let me get my marker situated. Plus 2 times that same pink something times a green something plus that green something squared. Now, I always like looking at the C value because usually the C value is something nice. And 25 is a nice and easy perfect square that you should recognize because that's 5 squared. Now, because that's in green, I'm going to come over here and put that in here. And again, this, before I continue, I'm sorry, is on page... Oh, duh, I had it written right there, never mind. This is on page 30, and we had a couple of examples of it. Now, let's come back over here to the pink. Now, I want 9x squared. Obviously, x times x is x squared, but 3 times 3 is 9. So, there we go. Now, before we write our final factor form, what I'm doing is breaking up this to make sure that it works. Now, 3x times 3x gives me 9x squared. 5 times 5 gives me 25. This is the one that you honestly actually have to check. Now, you can do this any which way. That's what I love about commutative property of multiplication. So right now I have 2 times 3 times 5. Now, actually that's not working. What did I mess up on? Oh, I put in the wrong number. No wonder I had such a big number. I wasn't thinking. See, this is what happens whenever you make up problems. Sorry. There we go. So now it makes a lot more sense. So here you can either say that that's equal to 2 times 15, which using your bank ledger, you know is $30. Or you could rearrange it and say 2 times 5 times 3, which is the same as 10 times 3, which is 30. Nonetheless, yes, it all checks. So therefore, you can write your final answer as 3x plus 5 in a set of parentheses and squared. I'm sorry, I was making something up off the top of my head and that's what happened. So here's my question. Would you like to stop here? Or would you like to do this weird problem that is not showing up in focus anyway? Are you good with your final answer on a square of a sum, or would you like to do one more problem and then call it a day? I'll wait to see your reply. Okay, I'm not seeing anybody saying that they want to do one last problem, which I completely understand. I feel tired as well, and it's about to be 6 o'clock. So we went over double A6, double A7, and double A8. If you watch this video and you're still having some questions, you're getting stuck, please text me via Remind, or send me a private message on the assignment, and I'd be more than happy to help. Thank you guys for joining, and I'll see you for sure next Tutoring Tuesday. Hasta luego.